Hello, and welcome to today's episode of How It Works. I'm Gunnar, and I'll be your host. Today we will be discussing the theory and purpose behind building an alternating current to direct current converter. The advantage of AC versus DC is that AC voltage can easily be scaled, while DC cannot. Power companies deliver AC voltage to our homes because of this, but devices like computers and cell phones require DC voltage. To explain the difference between AC and DC voltage, we will be going back to the drawing. Here we are, back at the drawing board. Well, we will be explaining the difference between alternating current and direct current. Alternating current has a sinusoidal wave, where the amplitudes go from the positive to the negative with equal magnitudes, while direct current has a constant voltage across the entire time. So alternating current has both a varying voltage in magnitude and direction, while direct current has a constant voltage. This will greatly affect the devices which is being used on. So now that you know the difference between alternating current and direct current, you may be asking yourself, why can't we power devices with both? Well, some devices, like computers, rely on voltage comparisons for their underlying logic, and if you were trying to power it with AC, it would cease to function. Other devices only allow current in one direction, like LEDs or light-emitting diodes. So here's what would happen if you tried to power an LED with alternating current. As you can see, the LED light flickers on and off, on and off. Also, there's a lot of wasted energy when the AC current tries to flow in the opposite direction. Here's how our resident expert responded to this wasted energy. Now, a simple solution to having current which flows in both directions is to have one LED which accepts current in one direction and another which accepts it in the other direction. This allows you to take advantage of both the positive and negative current flow. Apparently, while its design is more efficient, it still falls short of the desired efficiency and leaves room for improvement. We now go to a message from our sponsor. In order to get a more efficient design, we need the electricity to flow through the LED in one direction, independent of the direction of the current source. To explain how we will accomplish this, we will be going back to the drawing. Here we are, back to the drawing board. Well, I will explain how to use 4 diodes to create a current independent of the current source. Now, a diode allows current in one direction, but not the other. So, when you're using an alternating current source, as the current flows this way, it's blocked by this diode, but allowed by this one. So the current flows in the direction you want for the LED. However, when the current is flowing in the other direction, it is blocked by this diode, but allowed by this one. So you get current that's also in the same direction. While the use of diodes allows us to obtain a positive current through the LEDs, it does not give us the constant voltage source that we need. To obtain this, we will be using a device called a capacitor, which opposes change in voltage source. To show you how this works, we will be going back to the drawing board. Here we are, back at the drawing board. Now, this configuration of diodes does give us a current in one direction independent of the current source. However, it results in a voltage function which is similar to the absolute value of a sinusoidal wave. While all the voltage is positive, it's not very efficient. Now we can use a capacitor to smooth this out. A capacitor is a device which opposes change in voltage. Now with this capacitor, we get a voltage that's much smoother, although it is still a little dirty because it's not at a perfectly smooth level, where the magnitude is equal to the amplitude of the original V1 divided by the square root of 2. This results in much more efficient power for devices like cell phones and computers.
Alright, so here we have our input going out to our breadboard with our LEDs lighting up correctly and our AC to DC converter right here. And here we have the oscilloscope showing the dirty direct current that was converted from the alternating current to the direct current.
We now have a complete AC to DC converter. Let's see what our resident expert has to say about the final design.